Hello friends, welcome to Electronic Circuit Hub. So today I will show you the simulation of bridge rectifier in LTSpice. Okay, so here we have source voltage V1, then we have 4 diode D1, D2, D3 and D4, then we have load resistance. Okay, so I will run the simulation in LTSpice and I will show you the input voltage waveform, that means source voltage waveform. Then I will show you the voltage after rectification, after bridge rectifier. Okay, the uh, the voltage across this resistance R1, that is load resistance. Okay, so let us understand circuit first. So the sine pulse is 50 hertz sine pulse. So there is a peak voltage, positive peak voltage and negative peak voltage. So the positive half cycle, that means for 10 millisecond, for the positive half cycle, from here to here to here, the diode D3 becomes forward bias. Okay, and then it goes to the load resistance, and via load resistance it goes to the diode D1, and now diode D1 becomes forward bias and it completes the path from here. Okay, so for the positive half cycle, diode D3 and diode D1 conducts. Okay, for the negative half cycle, from here diode D4 conducts, then it goes to the resistance R1, then it goes here, from here to here it goes to diode D2, and then it completes the path from here. That means it starts from negative cycle and negative side and it completes positive side, right? So for the negative half cycle, diode D4 and diode D2 conducts, right? Okay, so hope you understand how bridge rectifier works. Now I will run the simulation, okay, and I will show you the waveforms. Before I show you the waveform, so generally we use in real time application, this diode is IN 1N4007, but this model is not available in the LTSpice, so I used this part number 1SR154-600. So in the practical scenario, you can use 1N4007. Generally we use 1N4007, right? And here I will show you the in source voltage. So DC offset voltage is 0. You have to select here sine pulse, then DC offset voltage is 0, and amplitude is 325 and frequency is 50 hertz. Okay, so if you want to run your transient analysis, go simulate, edit simulation command, and for this simulation I've selected the transient time is 200 millisecond, right? So now I will run the simulation. Let me run the simulation. Okay, here is something. Let me run the simulation. So I will show you the input waveform. So this is input waveform. Let me add cursor to show you two cursor. Okay. So from here to here, you can say this is yeah 50 hertz, right? This is 50 hertz, and the voltage is 324 volt, right? So from here to here we have 325 volt peak, and from here to here we have minus 325 volt. That means peak to peak is 650 volt, right? So this is the input voltage, which is called V in. Okay, V in. And now I will show you the output voltage from here to here. So you can see this is the positive half cycle and this is the negative half cycle. So during positive half cycle, diode D3 and D1 conducts. So the output voltage follow the input voltage, and for negative half cycle diode D2 and diode D4 conducts. Okay, so for the negative half cycle it also output also appears to the peak value. Okay, let me add a plot pane. So here I will show you my input voltage, and here I will show you the output voltage. Okay, from here to here, right? Mm, mm, mm. From here to here. Let me delete it. Mm, mm, mm. So this is the input voltage and this is the output voltage, right? Okay. So since you can see this is sinusoidal voltage, and here we have pulsating DC, not pure DC. So if you want to get the pure DC output, you have to have a filtering capacitor, okay, over here. So let me connect one capacitor here. The value of this capacitor, let us say 100 microfarad and 400 volt. Okay, 400 volt. So let me run the simulation again. You can see now we have sinusoidal input voltage, and we have pure DC with some ripple voltage. So you can see from here this is 322, and if you see here this is 303, this is around 300. So you have 22-volt ripple at your output. Now if you want to increase this capacitance value 470 microfarad, let us say. Now let me show you the ripple voltage. You can see now we are getting approximate pure DC. There is very less ripple component. Okay, so so uh, hope you understand how bridge rectifier works, and now you are able to simulate your own bridge rectifier in LTSpice, and you are able to see the waveforms. Okay, so thanks for watching this video. If you have any question, feel free to ask me in comment section.